Hey Algebra 2 students, this video is all about what a hole is. And I'm just going to show you one quick graph without a hole and then do a small tweak to create a hole so you can see the big idea. So here's our graph. I'm going to put this in Desmos, x plus 5 over 2 times x minus 3. So here is our graph. Right? Just as a self-check, kind of pause the video and think about, do you know what the x and y intercepts are, vertical and horizontal asymptote, and then unpause the video and I'll have them up on the screen. So here is our vertical asymptote. X equals 3 would make the denominator equal to 0, which is undefined. I'm going to hold down and make it a dotted line. Notice this is not technically part of the graph, but it's, you know, kind of an invisible line, so we're kind of making it visible so we can see it better. The x-intercept would make the numerator 0. Be negative 5, so here's our x-intercept. The y-intercept, if I plug in a 0, it looks like I'm going to get a negative value. It's going to be a 5 on top and a 2 times 3 on the bottom. So here's our intercept. I'm just going to make it maybe the same color as the other intercept. And then I just need my horizontal asymptote. Remember, the powers or the degree is the same, so it's going to come from the coefficients. So it's going to be y equals 1/2. And I'll make that dotted as well. Okay, so here's my graph. I've got all my details. Now, what we're going to introduce is a concept called a hole. A hole is something we have not yet seen, but think back to the Guess Who game that we did in Desmos with the different graphs. And when you guys were asking each other yes or no questions to figure out which graph your partner had, a lot of you guys honed in on these things that you called circles or points or dots. Now typically, like here I've got the x and y intercept highlighted. Typically we don't actually highlight those, so I'll kind of take those away. Right? Typically we just have smooth curves and we don't actually like highlight a specific point. So the reason that that specific point was highlighted was because it was a hole. So what is a hole, you might ask? I'm going to add in a line here and create an almost identical equation, except for I'm going to add something here. I'm going to add x minus 2 on top and to the bottom. So here's the green function. It's got that x minus 2 on top and bottom added. Notice it lines up perfectly with the red. So the reason it lines up perfectly with the red is because technically the x minus 2's cancel out. So it's really the same thing. But here's an interesting thing. I'm going to call this a different letter. When I do w of, see how this value is kind of like an interesting value. I'm going to use 2. Because it's like opposite, just like you do with your intercepts, or your x-intercept and your vertical asymptote. I'm going to plug in a 2 into the original function. It tells me when I plug in a 2, I get negative 3.5. I'm going to also plug in a 2 into my new function, f of x. It's telling me it's not defined. So here's what we're going to do. We're going to look at the value of 2. Right? If I look at the value of 2 here, it's going to be on this side, because the vertical asymptote is at 3. So when I'm trying to get to 2, looks like it's kind of right here. So here's my point at 2, right? Looks like there's that value. When I switch and I go to this function and I try and get to 2, did you see that little blip? It's really hard to see. Notice when I get to 2, it switches from a filled circle to an open circle, which is representing the hole. It's like really hard to see though. It is one of my pet peeves that Desmos doesn't automatically show this. If we wanted to show this, we could show the point. It's technically in the same spot that the old point was. If we wanted to, we would have to do something like 2 comma negative 3.5 and then hold it down and try and show that it's an open circle there to kind of mirror with what we're finding as we go and we get to that empty data point. But Desmos doesn't automatically show it. So you want to be careful. They won't automatically show you a hole is there. You would have to kind of trace along the line by holding down and dragging. So this is the concept of a hole. Notice the graph is nearly identical, right? The only difference is that one point here is a real point in the red one, but not in the green. So if you wanted to write out some details, I'm going to add in that x minus 2, right? What you would do for your details here is you would cancel these out and you would ignore them, right, for the y-intercept, the x-intercept, the vertical asymptote, the horizontal. So I'm going to fill in what we had for the original graph. So here are all my original values, right? If I wanted to also show where that hole is, I'm going to add a little spot here for the hole. For the hole, it happens when x is equal to a 2. Now the reason why that is, and I'm going to make a little bit more space, what we see algebraically happen is if I was to plug in f of 2 to the original function before I did the cancellation, you would get 2 plus 5, excuse me. So here's what happens when you plug it in. Both of the 2 minus 2's create zeros, and then they get multiplied with everything else. So this creates a 0 over a 0. So that's kind of the algebraic marker that you have a hole. And the hole's value is at 2. If we wanted to see where the y value was, remember it's the same place that it was on the original function. So if I wanted to actually find the value of that, I would plug it in after canceling and do f of 2, right? 2 plus 5, 2 times 2 minus 3. That's going to make negative 7 over 2, which is negative 3.5. That's what we saw from the graph. So the idea is that I'm going to put in my intercepts. Here's my y-intercept. It's almost negative 1. My x-intercept. I'm going to put in my vertical asymptote. Or sorry, my horizontal. And my vertical as well. But basically what we're going to see with this graph, right, it's identical to the one we had in Desmos, right here. The only difference between the original graph and the graph with the hole is that extra point down here where we have that hole at the value of x equals 2. And remember, where it is the same place along the line, so it should be at that negative 3.5 value. I'm also going to get a point, maybe, I'm going to find a point on this end, so I'm going to do like w of maybe 4 is 4.5 just to get a point. I'm going to get that point right here. So here's my sketch, right? And then I've got the hole is at 2 comma negative 3.5. 1, 2, 3. So I'm going to do an open circle there. And then what we'll see is that we connect those dots. And I've got my graph. So the only thing that happens with the hole is that you put the open circle. It's the same as the graph, x plus 5 over 2 times x minus 3. But for that data point at 2, you need to make it an open circle because originally plugging in 2 would not work, and it would create a 0 over 0. Okay, so I always do a cancel of the hole as my first step and make a little note of the hole being at 2 and do everything else like normal. So it's the same as before. There's just going to be a little open unfilled circle at that value that you have mirrored on the top and bottom. You're going to see it come up briefly on the OpenNote unit assessment, so this is something you could use. There's also a really good problem that deals with a hole on your homework assignment where you are given clues and write out a rational function based on your clues, and one of them is going to be about a hole. So go ahead and move on to your rational function review and hole homework, and that should give you some good practice to get ready for the OpenNote assessment on Friday.